Namastey Coders, I hope you are fine, doing well in your life. So, today is 18th February and we are gonna solve the LeetCode problem of the day. So, before solving the problem, uh, let me before solving this problem, so let me share you something. So, this video is the part of LeetCode problem of the day series. So, we are solving LeetCode problem of the day daily. And along with the LeetCode problem of the day, we have also started LeetCode 75 video series. So in which we are gonna solve all the problems from LeetCode 75. So LeetCode 75 is the most important coding questions which may came into your interview, right? And we have choose a structure of solving the problem such that the that will be helpful for in your interviews, right? So along with this, I have also created a WhatsApp group in which we can discuss multiple things like any doubt, any other questions, any algorithms, approaches. We can start some good projects for our resume and freelance work also. So that there are multiple use cases of a community or a WhatsApp group. So I suggest you all to join that WhatsApp group. Link is given in the description box. So that's all. Now let me start with the question. So we will solve this question in three steps, right? So first we will discuss each and every detail of this question in a very depth, so that we cannot we will hit this solution in our mind, right? So after that we will think of a native approach. We will discuss the native approach, then we will gonna optimize that native approach, right? So the construct question is construct smallest okay so construct the smallest number from di string. So actually I have solved this problem, so let me explain it to you, right? So di is a string in which we have given characters like I d. So I means increase and d means decrease. Okay, there is some rules, right? So the so we have to create a zero indexed in string num of length n plus 1. So 0 to n using the following conditions. So there is a conditions which are given. So num consist of digits 0 to 9. So num consist of digits 1 to 9. So num should contain digits from 1 to 9 only, where each digit is used at most once. So we can use only one digit, right? So we can use one digit only one time, right? If pattern I is increased, so we have to increase our so num I will be smaller than num I plus 1. So we have to increase the pattern, and if pattern I is decreased, then we have to decrease the pattern, right? Okay, we have to return the lexicographically smallest possible string now. So we have given this string I. So let's start with the 1. Then we have to increase to 2. Then we have to increase again, then 3. Right? Then we have to decrease. So we cannot decrease, right? So we cannot make it again 2, because then we will have two 2's, right? So this case will get violated. This condition will get violated because we can use one digit once only. So what we can do, also we cannot make it 0 or minus 1, because we can only take the digits from 1 to 9. So what we can do, we can either make it 2, 3, 4, or we have to make lexicographically smallest digit, right? So we will make this element 4, and then we will make it 3. So this is the case. If there is also okay, so then we will we have a increase, so we cannot make it a 4, so we will make it a 5, right? So we have d. Now we have a d, so we have already taken all the elements, right, from 1 to 4. Sorry guys, oh, actually I got a cold. So we cannot make it to 1 to 4, so we have to increase it, right? So we will increase it to 6 and then 5. Now we have again a d which is decrease, so we cannot decrease it because we have already taken all the numbers from 1 to 6. So what we can do, we can make it 6, we can make it 7, right? So then we can choose 5. Then we have again a decrease, so again we cannot take any number from 1 to 7. So what we have to do, we have to again make this 8, make this 7. Okay, what is this? Oh, sorry, with this sorry, where are we? Yeah, so we will make it 8, we will make it 7, we'll make it 6, then we have to again choose 5. So we are at the end of a string, so I think, yeah, 1 2 3 1 2 why the 3 is there? Okay, 1 2 3. Okay, so I made a mistake actually. We have to start from somewhere, right? So let me start from 1, then we have to choose this in so that is, so let's forget about this I, right? So for this case we have the answer. For if we choose again I, we have to start from here. So so we can choose this, right? Anyways, I hope you understand this problem well. So this is the given to us. We are expecting a lexicographically smallest string, and also the constraints are, we have pattern of length 1 से लेके 8 and pattern consisting only I and D. So these are the details which is given to us. Natively what we can do, so for discussing naive approach, okay, what we can do, actually we have discussed the naive approach in the discussion only, right? Because so we can iterate through all the element, and we have to check that while going through the decrease, we have to increase all the element in this slope, right? So we can make it like a mountain. So if we are decreasing here, right, so we have to increase all the previous element till the height. So what you can do, while increasing, so we have a base number, so let's start with the 1, and let's say we have 3 i's, right? So we have 1, then we have 3 increase, 2 3. Okay, let me delete it.
ज्वाइन कर ले भाई।
कौन सी
कशिश ने शेड्यूल करी
करनी है अभी?
आ जा अंदर।
So hi guys, sorry for the disturbance. Actually I got an urgent work, that's why I have to go. So let's again start with the native approach. So I think we have discussed the native approach, but let me try to explain it again. So let's say we have this type of pattern. We have 3 increases. So we will have to start from 1, right? Let's say we have to start from 1. Then if we have 3 increases, so that means we have to go to 2, 1 increase, 3 second increase, and 4 third increase. So we will count the 3 increases, then we have a decrease. So for decrease, for any decrease, we can store the highest point, right, in anything. So we can store highest point is this. We will have to go to that highest point and increase all the numbers in between, right, while decreasing. So let's say we have like either let's say we have to decrease 1, so we have to go to a highest point and increase it. That's 5, and then we will put the number at the highest point here. Okay, so numbers, so okay, now imagine we have again a decrease. So what we will do, we will go to the highest point and increase every number. So this is like 5, and this is the highest point, so we will make it 6, and then we will add 4 here. Then again if we have decrease, so we will make it 5, we will make it 6, and we will make it 7. and we will add 4 here. So that's what we need to do, right? In a if we have got an increase, so what we will do, we will make a new number which is highest point plus 1. So 7 plus 1 8. So that's what we can do in a native approach. So the time complexity will be, we have to, for increasing we have to iterate in n, but for decreasing we have to go through the list again and again. So that will make it n square, right? So this, the overall time complexity will become n square. Space complexity for storing this number, we have n, right? So hello, अंदर हूँ, बता कहाँ बैठे हुए हैं? तो आता हूँ, मेरे को टाइम लगेगा थोड़ा, मैं आता हूँ। तो हो तो गई बात, अब किससे बात करनी है? अरे हो गई ना बात, अब क्या बात करनी है बता तो। हाँ तो कर लो ना। अरे ठीक ठीक, okay. So sorry guys, so that's what we can do in a native approach, but let's see how can we optimize that approach, right? So we have got a time complexity of n square in a native approach, which is still good for n is equals to 9. I mean all the time complexities are very good for this. We can use time complexity up to 2 to the power n, but we need to do it in on, right? So what we can do, we can use a data structure called stack, right? So I hope you all are aware of stacks. If you are not, then I have uploaded a video of explaining what stacks are, right? So you can go through that video. So we will use stacks. So what we can do, while increasing, we will, hi guys, so let's start with the most optimized approach, which is using STACK, which is stack. I hope you are aware of stack. If you are not, you can go through my video. I will share the link in the description also, right? So how can we use stack, right? So whenever we are increasing, so let's say we have base number as 1. Whenever we are increasing, we are just increasing, right? Nothing else. So let's say we are increased 3, so we have increased 1 to 2, 2 to 3, and 3 to 4. 3 to 4, right? So okay, now if we are decreasing, right? So if we have a decrease, what we'll do, we will use stack. And how to use stack? We will put this 4 inside the stack, and we have one decrease, right? So we will put another element inside the stack, which is 5. And whenever we are ended with the decrease, or we are encountered with increase, we will append this to like this. So we have 1 2 3 here, then we have 5 here and 4 here. Again we have a increase, so we have 6, and we will also contain a visited array in which we will mark all the numbers which we have visited, right? So we have visited till 5, so we will use 6 here. And then we have 3 decreases. So what we'll do, we'll put this 6 inside this stack, right? 6, then 3 digits also, 7, 8 and 9. Then we will put these like this is 9, and then this is 8, 7, 6. So this is a straightforward strategy to solve this problem in ON, right? So as you can see, we have to iterate through this numbers only one time using this stack, nothing else. So so this we can solve in just ON and space complexity of ON, right? So this is the most optimized solution. There is also one solution using backtracking, which if you want I can explain you. So if you want, you can ask directly to me in the comment section, or you can join that group and ask me to explain to you. So that's all in this problem. I think, yeah. Let me explain you this code. We will make we'll make n means nothing but length of pattern. We will make a result as an empty string, and we will make a stack. We will iterate through the range. We will iterate through 1 to n, right? We will append it to stack I plus 1. So if we are at like 0, so we will start from 0. We will append 1, right? Because we have to start from 1, right? If we have at the last point, right? So if we have at the last point of this, we will append all the characters from stack to this. Either we are here or here, okay? Or the pattern is increasing. If we encounter an increase, as I have said, if we encounter an increase, we will append all the characters from stack in this series. Else what we'll do? We will just appending in the stack. That's all we are doing. So let's say we have 5 decreases only. So we are just appending 1, 2, 3, 4, 5 and 6. We have encountered the I is equals to n, so we will append all these in the decreasing in the reverse order. So the property of stack is last in first out. So whichever came in the last will get outed first. So 6 came in the last, will get outed first and appended to the result first. So we will get a string like 6, 5, 4, 3, 2, 1. If we have 1 increase and then decreases, so we will like 1. We have 1. We encountered the I, so that means we will add 1 to the result. So result will like 1. Then we have 5 decreases, so we will append from 6, 5, 4, 3. So similar like this. So this is all in this problem. I think I have explained you well. That's all from my side in this problem. I suggest you to join that WhatsApp group. If you have any doubt, you can if you have any doubt in any question in the world, you can ask directly to me in that group. I will definitely provide you some help with some guidance. Also, if you are planning, if you are preparing for placements, so I can guide you. I can provide you some good persons from the industries. I can provide their contacts, so that will be very helpful for you. And if our community grow, everyone will grow, right? So that is the key strategy. That is the mindset of growing the community. So that's why I am regularly working to grow the community. So thank you for your time. Thank you.